All set?
All set.
Okay. Well, thanks for coming. I'm glad you made it. I know it's early. I was just telling him I woke up at 8:25 this morning, and I had to check 2 clocks to make sure that I was reading it right because my alarm was set for 6. So everyone made it, so congrats. So this talk is called Kotlin in Action. I originally called it Kotlin in Anger, and all my British friends told me, like, that's an idiom that maybe not everyone quite understands. So I renamed it to Kotlin in Action, because that's probably a little less idiomatic. So just real briefly, who I am, for a little bit of context. I've been a Java guy since 1996, so I've been doing Java, at least, for quite some time. I'm a Java champion, I'm a member of the JCP, I do Java at my day job. And really, this is mostly just to say that even though I'm here talking about Kotlin, this isn't because I think Java sucks and what a terrible language it is. I'm not a Scala guy, after all. I actually really like Java, but I also happen to really like Kotlin. And in the 20 years that I've been doing Java, Kotlin is the first JVM language that's really enticed me to write anything other than Java for the JVM, for a number of reasons, which I hope you'll understand. But my world is fairly polyglot these days, so I do a mix of a lot of different things at Mongo because it's kind of how we do business. But sadly, no Kotlin yet. I'm slowly wearing them down, and hopefully someday there will be some Kotlin involved. So, with all the preamble out of the way, what is Kotlin? Well, it is a mixed paradigm JVM language. And it comes from Jetbrains. So what that means is that it's object-oriented, just like Java is, but just like Java 8, it has a lot of kind of like functional paradigms kind of built into the language, into the standard libraries. So it's a bit of an evolution beyond even what Java 8 brought us, but not anything quite as exotic as, say, Scala or Ceylon from Red Hat. So the design goal is to be very pragmatic. They will tell you that nothing they're doing in the language is new. You know, it's not a research language. They're not trying to forge new ground. They're taking existing known ideas that people know and love and work, and they're combining them in a very pragmatic way. And if you've ever, how many of you guys use IntelliJ? Yes. I was afraid it's going to be a room full of Eclipse guys, and this analogy wouldn't work. Have you ever been using IDEA and come across a feature, or your coworker says, hey, you should check this out, and push this keystroke and something amazing happens, and you're like, wow, that's really well thought out, and it's, you know, just such a thoughtful feature. Kotlin feels like that in a lot of ways. It's the same kind of thoughtfulness and intention to design when they were building the language. So it's pragmatic, it's concise, even more so than Java, which we'll see in some ways. And the best part for me is it's seamlessly, we'll put that in quotes, interoperable with Java. Anyone ever done any Scala work? A few. Have you tried to use Scala libraries from Java? It's weird, right? There's like weird corner cases. You're like, I understand why I have to do that, but it's weird. The Scala-ness starts to leak out of the Scala library into your Java code. And it's not always that great to work with. It's not bad, but with Kotlin, you don't really get a whole lot of that. There's a few places, because it won't be perfect, because there's 2 different languages. But there's not a lot of places where you have to do like weird stuff because the language is different. It was designed from the beginning to be as seamlessly interoperable as possible. So whether you're writing in Kotlin or in Java, using Kotlin libraries feels pretty natural. Now, any Android developers? This doesn't do much for me because I work on the server and I actually work on a driver, so I'm so far below mobile, it's never really much of a problem for me. Kotlin compiles to Java 6 bytecode, and so for most of us, we're like, who cares? But if you're on Android, what that means is you can actually write in Kotlin, you can use lambdas and you can use closures and you can do all this kind of fancy functional stuff that you can't do with Java 8 unless you're using like retro lambda. But because this compiles directly down to Java 6 bytecode, you can use all these kind of modern, kind of fancy language features and just compile straight to bytecode and go on. You can skip the retro lambda stages. So if you're on Android, it's a big selling point. If you're not, you probably won't notice. So why do I like Kotlin? it's a pretty low surface area. And by that I mean, when you learned Scala, for those of you that did it, if you'll recall, you had not only this language to learn, there's all this new syntax and this and that, underscores and operators, but there's also a ginormous, well, large, I don't know if ginormous translates, out of the Midwest of the United States, an enormous standard library. So you had the language, you had this library, and you learned both, on top of all the Java libraries that you're using. Well, Kotlin has a very, very small standard library, and it is, I won't say mostly, in large part, in my experience, it's extension functions on top of something else. So as we'll see, they've added extension functions on like an input stream. You can say input stream.read text. And so rather than creating a buffered reader and reading until it's null and appending to a string, you can say stream.read text and you get a string with the entire contents of whatever that stream is in one line of code. So they've added a lot of extension functions to the existing Java classes that we all know and love, making them that much nicer to use. As I said, you can easily reuse existing Java libraries. It's very, very easy to consume Java code from Kotlin, and mostly vice versa. And you can extend Java libraries. As I was just mentioning, the standard library does that, but you can add extension functions to anything that you want, whether it's your class or not. And that makes it really nice. If you have to consume a Java library you don't like, you can reduce your boilerplate just by adding some extension functions and hiding all away. So at a very high level, that's the what and the why of Kotlin. Now, the way that I wrote the abstract for this talk is I like to call it, I'm going to have to mirror my displays now because the way I like to structure most of my talks is that I like to refer to them as giant code reviews. Or this one is a giant code review. So I'm going to spend most of the time in my IDE. It's going to do that to me. I just want a bigger font, guy. It's supposed to be a bigger font. Can everyone read that? Let's see the actual code. Is that easier to read? That's actually a Gradle file, so don't mind the man behind the curtain. Get the proper project. This is what I was doing when you guys were walking in. I was closing the projects you don't really want to see. So, as such, seeing as this is a giant code review, as I like to call it, I like to keep it fairly free form. So if there are questions that you have as we're going along, the idea is that we can stop anywhere you like and start talking about whatever questions come up. And we'll open all three. So I have a selection of 3.5 projects that we can walk through. We'll spend most of the time in one. But we'll walk through some language features. We'll kind of see them in context, in action. And if you guys have questions, just raise your hand. And if I don't notice, yell at me. And we can stop and talk about whatever we like. So let's start with, if I can find where it went. Did it not open it? Window. It didn't open it. It's supposed to open them all, but it clearly didn't. So I have a project called JavaBot, which when it was written, was actually written in Java, but I converted it to Kotlin because why not? So what you're looking at is this is the main class in the JavaBot, and it's an IRC bot, which is not important. But the thing to note about this project is that this has been my science experiment for about 15 years now. Anytime I want to learn something new, I do it in this guy. So the code can get a little gnarly sometimes. There's a lot of mixed paradigms going on. It had a map for a database at one point, and then I put it on Postgres, and now it runs on Mongo, and now it runs in Kotlin. There was a Scala port for a while. So there's been a lot of back and forth in this project. So there is code that is uglier than I would probably like to show people in public, but we're here for the syntax and not how great I am at writing code. So, but the thing to note about this project, and the thing that makes Kotlin easy to experiment with is, let me see if the menu will actually be viewable. I'm not sure if it did the font or not. So if you go to, where will it be? We'll just go to the context menu. There is a function. Is it under code? I know the keystroke, but I can't really show you the keystroke. Where did it go? Anyways, there's a function in IDEA, and we'll find it later, called convert to Kotlin. So you can actually take a source file and hit Command Option Shift K. It's some sort of keyboard chord, and it will convert your Java code to Kotlin in the blink of an eye. So this project is, I don't know how many dozens and dozens of files and hundreds or thousands of lines of Java code. I just went to the root of the project and said, convert to Kotlin, and like 3 seconds later, everything was converted to Kotlin for me, which makes it really nice because you don't have to learn all the syntax up front necessarily, and it'll do much of the heavy lifting for you. So this is what you're seeing in this project is a converted one, which is kind of nice. So let's get started. So this is a class, obviously, and the thing to note, one off the bat, is Java classes, or Kotlin classes, are closed by default. So everything is final, essentially, in Java terms, which is surprising for some, and some get angry when they come to Kotlin. It's like, why do I have to declare my class open if I want to extend it? It's a design decision they made for a number of reasons. I personally don't really care for it. I used to work with a project called Wicket that had made everything final, and then you try to do anything with it, and it's like, I can't subclass it or override it because they made it final, now I can't work with it. I prefer open by default, but the designers don't. So if you want your class to be extendable, you have to declare it as open, which I did in this case. Another thing to note is, you'll notice the first thing I did is I deleted the keyword public. Everything is also public by default. And now if you've done a whole lot of Java, your inclination is like, weren't we supposed to make everything private by default? For decades they've been telling us, hide your stuff and make it private. They did, Jetbrains wrote a scraper on GitHub and analyzed thousands of Java projects, and they found out that the vast majority of them, they were all public classes or public methods. It was just public everywhere, so everyone's writing public, whatever. So being pragmatic about it, they decided that's a lot of code that we don't have to write. If we're going to be writing this by default anyways, why not just make that the default, save ourselves some keystrokes. So it is public by default. There is private, of course, if you want, if I can type. And there's also one called internal, which is a little bit like package private, but it's a little bit more restricted than even that. To me, this starts to hint a little bit at kind of some more module-y sorts of stuff, but there are no modules in Kotlin. They are waiting for Jigsaw like everyone else, except for Scala, apparently. So open by default. Now, I was going to wait, but it's here, and there's a screen full of it, so let's talk about it. To start off, you declare everything, all your fields, your variables, whatever, either var or val. And if you're a Scala guy, that'll sound very familiar. It's called a person. Var is a mutatable. You can reassign it. Val, you assign it once. It's essentially a final variable. They do, in Kotlin, it is the inverse of Java. So it's the variable name, colon, and then the type. So that flows fairly comfortably once you get used to it. It does, like I said, my day job is Java, and I interview a bunch of college students and interns who want to come work for Mongo. This does mess with my head because Go is also very similar in this way. It does take a little bit of getting used to, and it's sometimes hard to revert back to Java when you need to. But this is the way they do it. Now, without belaboring the point too much here, because this is something I want to clean up, but I left it to show you guys. These are all injected fields. If you've ever used Juice, that's what's going on here. Now, the problem is, if I don't have this, I get red squigglies. Because Kotlin and the syntax compiler, it doesn't know about Juice. It'd be a dumb thing to teach your compiler about Juice. And it wants to be assigned a value. Because Kotlin has nullability in the type system. So in this case, because I have this config.dao will never be null. It's guaranteed by the compiler to never be null. But I'm not assigning it to anything here. And so the syntax gets a little crazy. If I were to do this, it would be finish. You can see the red squiggly went away. And the injector will come back in later and inject it and everything will be fine, but I'm still carrying around this nullness that I know it's never going to be null because I know that juice is going to inject this. And we'll get to the nullness checks in a bit. But I don't want to be carrying that cost around. So what I'd want to do is I want to say this is not nullable. It's guaranteed to be not null, but the compiler's not happy because I'm not giving it a not null value. So they added this concept of late init. And this is, I think this is primarily for the Android type people, because the correct answer here, of course, is to use constructor injection, right? So you can never construct an object that's not usable. That's the proper way to do it. I'm not doing it here because, like I said, this code base is, 10, 15 years old, and I did a lot of stupid things growing up, and I haven't cleaned it up yet. So in this case, I'm slapping late init on everything. And what this tells the compiler is, I know I haven't done this yet, but I will initialize this in a minute. Just give me a second. It's not great from a non-Android perspective, and of course, there are ways to fix it. But this gets around it, because in Android, apparently the option is you can't do constructor injection on certain things. You have to create your whatever, hand it off to Android, and they start injecting things for you. There's nothing you can do about it from the developer perspective. So this is a bit of an end run around the nullability in the type system, and it's useful in places. For me, it's a bit, it's a bug in the code if I end up doing this. Clearly, when I started this, I loved it, and I just slapped late init on everything. But I've since had a change of heart, and I left it because I wanted to show you guys the options of what it looks like. So these are a bunch of fields. So as we start digging into things, you'll see a few interesting tidbits. You never use the new keyword in Kotlin, which is sort of nice. Again, it was considered a little bit of boilerplate. We know that we're constructing an object, so why do we slap new on everything? So in Kotlin, as you can see right here, we're just, I don't know how well that, I like to highlight code, and sometimes it doesn't show up on the screen properly. Here we're creating a tree map. It's a standard Java util tree map, nothing exotic about it, but we're not actually saying new because Kotlin, it knows, like, I know you're creating tree maps, don't bother. But it uses generic, so it looks just like Java in this case, but I don't have to use the new. You'll also notice that I did not declare the type for all operations map, which is itself not great, but the type inference in Kotlin is actually really quite nice. So in many, many cases, I won't say most or all because you never know, the compiler is smart enough to know, it's like, oh, you're creating a tree map. So in this case, if I were to declare, you can say, if you're like me, and every once in a while I was like, I'd really like to see that type because I've been doing Java too long and I really want to know what my type is. You can actually tell, in this case, IntelliJ, to specify the type explicitly. And you can do that. There is, I don't think there's a function. I thought there was a mutable map function. There's a couple of places where this will make a little bit more sense. You can create a list of, in fact, I just saw it. Okay, this. In this case, it'll assign the explicit type of a tree map because that's what we asked for. But in the case of list of, there are interesting things to be done here. This comes back as a list of string, which might not be, it's like, of course, it's a list of strings, not that surprising. But what will surprise you is that list is immutable. You can't add anything to it, which may not be what you want. There is an interface that they've added called mutable list, which may or may not import properly. So if you ever want to add to a list, you have to make sure that it's a mutable list type and not a list type. So sometimes showing the explicit type is handy because these helper functions, they're not quite list literals, which everyone I think wants by now, but they're closer than having to say new array list, which I do down below. But there is it's not going to cooperate with me. There's a function to get a mutable list if you want it, or you can just explicitly say, I really want an array list, and it will show up as a mutable list down the way. So those are how fields are defined. It looks, there's nothing terribly different about it. It's slightly tweaked from Java, but most Java developers should be able to sit down and at least kind of figure out what's going on here. But I do want to show, while we're here, there's a couple of things that Kotlin adds. You can, Kotlin has delegation when you assign it, which can be very, very useful. In this case, because it's an IRC bot and it has certain prefixes that if you want to trigger the bot, you have to prefix the message to it so the bot knows that you're talking to it. In this case, it's a dynamically generated list, and I want to be able to define it here, but it uses functions further down in the class that haven't been initialized yet. It has to load data from the database before, like this getNick function returns anything. So if I were just to say start strings equal list of getNick and the tilde, I would actually get, I think, a null and a tilde, because getNick doesn't have the data that it needs yet. So what I want to do is I want to tell it, don't evaluate this just yet, but let's do this later. So you can do a lazy delegation. So here I'm saying, this is a list of strings. I'm going to delegate it by using this lazy function. So this is a function that gets evaluated the first time you try to access the start strings field. And then it'll evaluate whatever the closure is that you give it, and whatever value comes out of that closure will get assigned to the start strings field and then sent back to wherever you called it from. So in this case, so I can define that it's lazy, I can tell it what it's eventually going to be at some point, but that lets me make sure that I can declare this as a non-nullable type, as opposed to waiting later and saying, if this is null, then go fetch the data, then set it, and then again, I'd be incurring the cost of this nullable field all the way down the line. So I lazy init it comes back as null. It's sort of like late init, but it's all internal, as opposed to late init, which assumes that there's an external process that's going to come back later and do things. So, didn't get my script out. So let's see here. We don't have any constructors here to speak of, so there's another class I'll show you. But I will show you down here. We have an init block. So in Java, it would look like this. Has anyone ever actually written one of these naked initializer blocks? Most of the time it's static is when I do it. I've never actually written one of these blocks because it feels a little weird. But this is essentially what that is. But for sake of the compiler and making parsing simpler and the language simpler, they added this init keyword so that it doesn't look like a closure to the compiler, and it knows that this is an actual initialization block. There is no static init block for a number of reasons, which I'll show you some of that as well. So this is run, I forget what the ordering is, if it's before or after the other explicit constructors, but it is run during the construction phase of the object. So functions look fairly simple, fairly similar for Java people. It's called fun instead of function. And again, you can declare it public, private, kind of whatever. This returns nothing, but as you can see, I don't have void, I don't have anything else. There's just nothing at the end of it. If your function doesn't return anything, you don't tell it to do anything. But if it did return something, which we will look at, let's look at one of my entity objects, because they do have functions that return stuff. Now this is pretty gnarly code. It's a lot of weird IRC stuff. But for example, let's take a look at this URL encode function, which does what it says on the box. It takes a string and it calls URL encode on it, and then it returns a string. So just like declaring a field, the return type is a colon and then whatever the actual type is. While we're on the subject of types, most of it is fairly familiar. You can use whatever Java object you want. Kotlin doesn't have an int. It'll turn red. You could do integer if you want, and I think, yeah. As you can see, it turned IDEA highlighted that in yellow, light brown, whatever that is. And this will work, this will compile, but it's not idiomatic, and if you hover over, you probably can't see that because the fonts never apply to those tooltips. But it says this class shouldn't be used in Kotlin. Use kotlin.int instead, which they're just saying to do this. As you can see, the yellow goes away, and now everything's happy. So instead of lowercase int, it's capital int. Everything is an object in Kotlin, so there are no primitives to speak of, but you can use them as primitives. I want to believe that the compiler does magic behind the scenes to make sure it's not boxing when not necessary, but I haven't looked at the bytecode, and I couldn't tell you for sure that it does. I won't say the right thing because it's hard to say, but that is what it looks like. And then there's float. I think all the rest pretty much look like what you'd expect. It's just int is a little bit different. I guess they couldn't reuse integer. I don't know. Excuse me, but all your numeric types are there. So that is a function with a return type. Put it back the way it should be. So this is an interesting little tidbit while we're here. You can see, can everyone see the backticks around the in keyword there? In is actually a keyword in Kotlin, which if all you're writing is Kotlin is fine, but I remember I converted this from Java, where I can use the word in as a variable name, but it's a keyword in Kotlin. So rather than make everyone rename everything when they convert to Kotlin, the Jetbrains guys decided to add a little escape hatch. You can do the backtick around whatever word that you want, and you can use virtually any keyword now as a variable name because it's escaped. I can't imagine this happens terribly often. If I cared more about this particular function than I did, I would probably rename it because one, it's a keyword, and two, it's a terrible variable name. But there it is, and it works, so there's that. But let's look at some constructor fun. Now, so bot listener is the one place where I have actually cleaned up the late init stuff because constructor injection is better, and that mostly scrolls off the right side of the screen, so I'm going to fix that briefly for you. Now, I hate keep making Scala comparisons because not all of you do Scala, but that should look familiar to anyone who's done Scala, and a number of languages do it this way. So in this case, it's a public class, it's not open as you'll notice, and I'm applying the inject annotation specifically to the constructor. Now this is slightly more complicated than it needs to be because I'm using juice, and so there's a little bit of syntax work that have to be done. If I wasn't using juice and I just created everything by hand and nothing mattered, it would look like that. So you'd have your class name, open parentheses, and then a list of everything required to construct your object. Now there are two things at play here. What you see here, everywhere where you see private var, whatever, you're actually declaring fields on your object. So all of these, in this case they're private, so I can't see them outside, but I could do this. And then what that would do is not only does my constructor take a throttler reference as the first parameter, but that's also exposed as a public mutable field on my class. I could do that, and now that's a public final field on my class because I didn't give it a modifier, an access modifier, and it defaults to public. Very handy. In this case, no one else outside the class needs it, so I declare it private. So all those are fields. Now, if you were to, and you can declare private fields this way as well, or constructor parameters that aren't fields, but I'm not doing it here. But in this case, I'm actually using a constructor injector, so I have to give it an inject so Juice knows where to inject, but then I also have to explicitly say constructor because the language needs something to hang that annotation on. So in this case, I'm telling it I'm going to annotate this constructor like it was a function. I don't think I have. This is a new project that I started this week that we might talk about.
So where does all the constructor code go? You have logic and constructor.
In the init block. So you can, in the init block, you can reference all those fields, whether they end up being fields on the class or just parameters in the constructor. You can access them all in the init block. And I don't think I have an example of doing that, because for the most part, for me, constructors are fairly dumb, just assign things, but it happens. I mean, we did have that one init block minimize you because I'm not going to talk about you. We did have the init block.
Yeah.
Oh, here's one, actually. For whatever reason. I'm just calling up update method at the end of my constructor. Whether that's great or not, it's probably not. But this is what it would look like if you wanted to do something. But I do think in this case, there's a bit more work being done here. And again, I'm not referencing any fields, but you could in the constructor block if you wanted to. Now what I hope to find, okay, so this is a separate project that I work on. I have most of my Kotlin work is in side projects to explore things. This one has to do with testing some Mongo stuff, and that's not terribly important. But in this case, this is a simple test class. So this is actually a test in G. Anyone test in G? Ever used it? A couple of you, most of you probably JUnit people, right? Either one works. I prefer test in G. This case happens to be a test in G test, but JUnit works as well. But in this case, it's a test called single node test. There are no constructor parameters, so you can see there's no parentheses here. So it's an empty constructor, a nowhere constructor, but it extends base test. So like with everything else, it's a colon and then the type that you're extending. And here you have to actually call a constructor. Now nothing, in this case, I want the nowhere constructor in the superclass, so there's nothing here. But if I were to pass parameters up, this is where I would pass anything that happened to come in. And then here, if I wanted to, it would, highlighting. Here, I would say if this was a foo string, I could do that too, I guess, it doesn't matter. And then bar, we'll call it an int. What window are you? Go away. There we go. So in this case, I'm passing single node test takes two parameters, foo and bar, and then I'm just going to pass those up to the constructor. And then I would just pass those by name to whatever constructor I was going to call. In this case, it won't work because that one doesn't take anything. So let me pull up. I had a script and I didn't. I was rushed and I didn't get them open. Kotlin and anger. See, there's my script, and you can actually see it used to be called anger. So we've seen annotations. Let's see. Oh, right. Let me see if I have. Now, was it Java 5, Java 6, Java 5 and Java 6 introduced the override keyword. What happened to my find? Override. Oh. Case sensitive. What is all this stuff? So Java 5 introduced the @override annotation, which is mainly just a compiler hook to say, I really did intend for this thing to override something in the parent class, right? It doesn't really do anything other than that. And at the time, only applied to classes. And then Java 6 opened it up to say, I'm trying to override interface methods. And that was nice, but it's all still just, it was compiler, it was bookkeeping, it didn't really matter in the grand scheme of things. Kotlin took the opposite approach. When you want to override something in Kotlin, you have to explicitly say, I want to override this. It's enforced by the compiler. If you don't use the override keyword, it'll actually fail to compile, mostly. So this is a compiler directive saying, I'm doing this. So this is actually part of the language and part of the spec, and it's required when you're doing that. And it's mostly nice, but I do forget it quite a bit. All right. So yeah, so everything's closed by default. Okay. So in BottleRocket we have that's not supposed to be. Okay, so let's take a look at some other stuff. Now, it's a little bit of a wall of text, and there's some interesting things going on here. So one of my favorite features of Kotlin, and one I wished that Java would pick up, but I don't think it'll ever happen, but you never know. Kotlin has default parameters and named parameters. which makes a lot of things so much nicer. If you've ever written like a long Java method, and you're passing in foo and bar, null, 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 3, true, null, null, null. You write it, everyone hates it, but you have to fill every slot, right? And it's terrible. So Kotlin fixed that by introducing default parameters. In this case, a constructor takes a whole bunch of stuff, but I don't necessarily always want to do it. In this case, what I'm doing is I'm modeling the Mongo config file. Not terribly important, just except to point out, whenever you're configuring almost anything, really, you never really want to deal with the entire configuration file. There's a few things that you want to tweak and get on with your life. You don't want to fill out the whole form just to pass in a few values. So in this case, this is the root level of the configuration, and there's a bunch of stuff that can happen in there. But if I'm only caring about, I just want to change the port. I don't have to fill out kind of all this other stuff. How am I going to audit it? What's my sharding policy going to be? I just want to change the port. So in this case, I can create a configuration object and pass it nothing. And I will get the default constructor, the knower constructor for all these parameters, and it'll just do it for me. So whenever you're calling it, config test. So whenever I'm calling it, and I'm doing a bunch of cheating stuff, which we'll get to. Let's just go to the bottom, and I'll write you a new method. So I can just say configuration, and it's going to ask me which one, because 26. So that's all it took to create what I just did. But there is, in that, there was a parameter called net, which takes a net instance of how to configure things. So I could say net equal net. Now this is still, and it's going to want to import some. This is still essentially what the constructor did, because I'm not doing anything to net. But net takes a value, and one of which is the port. So I can say run it on port 1000, or this is Linux, so let's get above port 1024. Can everyone see that? I can't scroll up any higher because it's at the bottom. That's better. Everyone can see that? So in this case, all I had to do was pass in the one thing that I wanted and tweak the one thing that I want, and everything else I got for free because of these default values. And I cannot tell you how much I really like this feature because clearly it's way less code than writing in all 12 objects that had to come in or passing in nulls. So default parameters. Now, it's 9:40. There's a lot of, there's a very nice feature I want to get to, but I want to make sure that we do other things first. Because when I gave this at Java 1, I got very excited about this other thing, and there's probably some other stuff you might want to see. Let's talk about interfaces. Okay, so close that window. So this is an interface called Version Manager. Yes, I'm glad we went here, because the other thing is more interesting. So this is what an interface looks like. Looks like, just like Java, except you might notice that there's a val version on this interface, which you can't do in Java. You can't declare a field on an interface. Not yet, anyways. So this is a little bit different in some ways. So what does this look like in practice? This is probably not great Kotlin. There's probably other ways to do it, but I've been doing Java for too long to change too much. So this is the base version manager, which is an implementation of version manager. Whether you're extending classes or interfaces, it all looks the same. In Java, you extend a class, but you implement an interface. And if you get it wrong, the compiler gets a little twitchy. But this looks exactly the same, which is nice because you don't really have to care necessarily what the parent type is at that point, because your class is just going to assume that interface. So I'm going to close this for just 1 second. But you'll notice that this class takes a val called version, and you can see that it's overriding it. So because I've declared in my interface that this interface has a field called version, now every class that implements this interface has to declare a field called version of type version. Yeah, I was trying to remember if you could actually rename the field, but you can't because a contract says this interface has a field called version. And it shows up as a constructor parameter, and it's public, so it is now a public field on your class. I want to, before we get into that companion object, what it looks like whenever you're accessing fields is probably an important thing to do. In Java, of course, we make all our fields private, and then we add getters and setters. Unless we want it to be immutable, and then we just write a getter, and then no one ever can set it. In Kotlin, that's not really how it's done. And so let's take a look at this. So in this case, we have a class called, or a reference called event, and it's of type message. Now, if we look at message, it's a fairly simple-ish class, I suppose. It has some fields of various types. And in this class, if you look at, that didn't work out well. Maybe you can read it, maybe not. There are no gets, there are no setters on this. So every field in Kotlin you access directly by name. And what the compiler does is it will synthetically say, I want to go fetch this field or set this field. And most of the time that's fine, because most of the time you don't have any logic around your getters and setters necessarily. But we're Java people, so we write getters and setters, right? So Kotlin kind of short circuits that a little bit, in that you don't have to do that, and the compiler takes care of that for you. So then what that means in practice is that whenever you access those fields, you just do that. Now, you may be asking yourself, but what about if I want to add validations for sets? We can't just let people start setting our fields willy-nilly. That's why we write setter methods, right? To make sure that they don't pass in numbers that are too large or empty strings or whatever. The way to do that, and I will do it on, I think, tell. Yeah. Okay, so in this case, tell is just a field I'm declaring, but it's not a constructor parameter, and it's easier to do it this way. So in this case, I can do get, and I can define my getter. And then this syntax changed. I think it's just field. So if I wanted to write a getter, and maybe I wanted to mutate another field before I return this particular value, you do this. And it's a little bit different because you can't just say, I couldn't say return tell, because anytime I say tell, it's going to try to go access the getter, which I'm defining, which then goes accesses the field again, and you get Stack Overflow. So what the language does is it introduces a synthetic field called field, helpfully enough, and then that's how you refer to the particular property that you're trying to do or whatever. And then set looks, a set would look like this, and then at this point I can say, I think that'll work. My squigglies go away. Not quite.
It's attached to the field just by...
It's attached to the field by proximity. If there was something in between the val tell and any of this, the compiler would break because it doesn't know what you're talking about. So that syntax isn't quite right because it's not something I do terribly often. But if you wanted to write a custom setter for that field, it would look something like this. I'm sure there's probably a type that's wrong. The problem this, I think the syntax is actually right. But you can't write a setter for a val, right? That's the whole point of val is you can't set it. Silly me. Anyways, so if you wanted to make sure that they didn't pass in an empty string, you would write a setter like this before you actually set it. Yes?
Actually, one remark and a question.
Sure.
This, and I know this is blasphemy probably, but this looks a bit like .NET, the way that .NET handles...
It probably is.
Funny thing. But what about when you want to keep fields private?
You want to keep them private and do setters? Or just...
Because Kotlin gives you the setters, but what if I want to keep them private, as in fields that I only want to use internally in the class?
like that?
Yeah, it's just like...
Now, I've not tried it, but you ask an interesting question.
Because you said it, but the set is still good.
Yeah, so now in this case, the getter is public, so you can access it outside, but it's immutable to the rest of the world. So you could do that if you want. So like I said, this syntax I don't use personally a whole lot because most of my getters and setters are pretty dumb. But there are cases where you might want to do something like that, and it's fairly trivial. This syntax has changed quite a bit over the years. So I've been doing Kotlin a year and a half, 2 years now, and it's still a pre-1.0 language, so the syntax has changed a lot. So there's still a few things that I learned the old way, and I haven't done it since they changed it, so there's a few things that I'm still bumping up against. Okay, so I'm getting the 5-minute warning. So I'm going to do like a quick potpourri of things, and then I'm going to try and answer as many questions as you have. Just real quick, Kotlin has string interpolation. For those of you who know what that is, in Java, you'd have to say like string, quote, plus some variable, plus, quote, string, plus, or what I started doing lately is a lot of like string.format and then anchors and whatnot. You can just do it directly in your strings in Kotlin, which it can be nicer unless you get crazy with it and then it becomes as unreadable. But you would just say $, you could do, here. You can keep it simple and you can say $value if it's just a single whatever. In this case, I want to put the nick of the user, the IRC nick of the user there, so you have to put braces around it. And you can even do more complex expressions inside there. In this case, channel might be null, right? So it may not have a reference. And if I just said channel.name, I'd get null pointer. But because channel is declared as nullable, the compiler forces me to deal with that at the time that I use it. So if I take off this question mark, you can't quite see it because it's tiny, but there's a red squiggly underneath that dot, and the compiler is telling me this thing might be null, and you have to put some checks around it. In this case, it can be as simple as question dot, and then if channel happens to be null, it does not try to dereference that name field. So that's all fine and good, but now I still have this null value hanging out because there's nothing left to resolve there. So we have the Elvis operator, I believe this is referred to, question mark colon. So what it's saying is, do the thing on the left, that's what I really want, but if it's not there, then in this case, I'm going to return a value of an empty string. So I mean, in this case, I'm going to get the channel name or an empty string if channel happens to be null. And the compiler enforces that so that anywhere it might be null, you have to do a check. And if you end up getting a null pointer in Kotlin, a null pointer exception, it's because you cheated somewhere and you shot yourself in the foot. Now, I will say that when I converted this code base to Kotlin, I found all kinds of bugs because this is one of those projects you're up late and you're hacking on it and you're just writing code because it's fun, you're learning, you're not really paying attention to what you're doing. Apparently, there are a lot of places where I can get a null pointer that I never bothered checking. But just the simple act of converting it to Kotlin brought out all this stuff where I should have been a bit more rigorous in my code. So there's that. I still have lingering references to string format because it won't switch that over for you automatically, unfortunately, so I have to do it by hand. So there's that. So 3 minutes technically. I want to show you one of my favorite features of Kotlin. Oh, no. I'll show if you're interested, I'll show you afterwards. I want to talk about static real quick because there is no static in Kotlin. Oftentimes you have like static constant fields and whatnot. So Kotlin has classes and it has objects. And every class can have multiple objects defined inside if you want, but it also has this companion object. And in this case, anytime you want a static field on your class, in Java, in Kotlin, it would be on the companion object. And now I can refer, this is my logger, because your loggers are always static, right? So in this case, I can now refer to this log reference as base version manager dot log. And you can reference it as if it were static, but it all happens on val. But you can have functions inside it. In this case, when is more or less like a switch in Java, but it is an expression, whereas in Java you have a switch and it's the statement. There's no return type out of it necessarily. It's just there. When is an expression, so you can actually use it in this case in a return statement. So there's that. And the one thing I want to point this out because it will confuse people, I'm sure. It took me some time to find it. So the ultimate question for every application is how do I run the thing, right? Right. So, very briefly, here's our public main, and it looks, ultimately it's Java, right? So public static void main, array of strings, right? Well, there is no static, right? So in this case, we have to, we're declaring it on the companion object for the main class. Public main, now you see this JVM static. That's an annotation. This is one of the places where Kotlin starts to leak out a little bit with the interop with Java. It's not bad. If I didn't have this at JVM static, in order to refer to this function, I would have to say javabot dot all caps instance dot companion dot main. It's not great, but it's, Java's verbose anyways, so not terrible. But what this JVM static does is when it compiles, the compiler will expose this function as a static method hanging off the javabot class. And then you can just say javabot.main. Not that you would, because it's a main function, right? And it's just there for starting Java. But this is how you would expose it so that you can actually run your application on the JVM, which is probably an important detail. Okay, it's technically 9:50, which is I should stop for questions. I'm happy to answer questions, or if everyone wants to see a really cool feature, we can go to that as well. Preferences? Question?
I want to know what the Java is there.
Oh, okay. It's a good question. So the question is, what is this .java thing? So this is my type, right? And this is me saying, I want the class object for this type. But this is a Kotlin class. So javabot : class is the K class from Kotlin. But I don't want the K class, I want the javalang class. So that's what the .java says. It's slightly weird. I kind of get a little bit of joy out of it because .java, it's the source file. So it feels a little bit like you're referring to the source file to the Java code, and I giggle every time I have to do this. But that's how you escape out of the Kotlin-ishness of your application and get down to the actual javalang class that you'd have to pass around for this or that. So, any other questions?
Just a quick question. This seems like is this just different from Java, or do you feel like it's a great improvement when you're writing the code? Because a lot of the things you showed looks cool, but you can also say they're just maybe just different, not necessarily a huge improvement.
Yeah, so the question is this better or just different? Ultimately, the question is like, why would I do Kotlin versus Java? And that's a fair question. Let me, if I can, because it's on the other thing. For the most part, if you're stuck on Java 6, like I am, and you can't target anything other than Java 6, say you're on Android, and you want some of the more modern features, Kotlin is a great option. If you're on Java 8 and you're happy with Java 8, it's a little bit of less of a compelling argument to say you should switch everything to Kotlin because you can get most of this in Java 8 already. So I'm not going to say that Kotlin will be absolutely dominant in everything you do, but it has some nice points. This is just real quick, if I can find it without running out of time. I can't find it. The way that you do streams in Java, so you have your like list.stream.map.filter, it's better than not having it, but it's still a little cumbersome. The Kotlin syntax is much cleaner. I can just say list.map. I don't even have to give it parentheses. I can just give it a closure, and then I can say .filter and closure. And then when I'm done with it, what comes out the other end, because I started with a list, depending on what your pipeline is, what comes out is a list. And in Java, you'd have to say .collect, collectors, .toList, which is not bad, obviously, but it's not great either. So there are little tiny things like that that might persuade someone to switch from Java 8 to Kotlin, but yeah, it wouldn't be super compelling at that point. So.
Yeah, we have to end, I think.
You're going to cut me off?
Yep.
All right, that's it. If you want to see the cool feature, I'm happy to show you. If not, thank you so much for coming and enjoying my super fast ramble through Kotlin.
Yeah, let's thank Justin for his...
Just real briefly, while you guys are filtering out, if you wanted to see I don't know if that'll come up. If you wanted to see some resources, these are various websites. There's a Slack channel, there's an IRC channel. Kotlin's all on GitHub. Everything's open source with the Kotlin, the compiler, the whole bit. But there's all that. So thanks.